Chapter 2 Dead Planets, Living World. 8 planets ring our Sun. The more we learn about the planets, the more unusual Earth seems. Each of the other planets is a dead and deadly place. Only our Earth is a living world. What is the solar system? The solar system is made up of our Sun, 8 planets and their moons, and thousands of other bits of matter called asteroids and comets. Gravity holds all these things in space near our Sun. The Sun itself contains nearly 99.9% of all the materials in its system. Each of the planets swings in a great circle around the Sun, traveling through space at terrific speeds. Mercury, the planet closest to the Sun, travels at 110,000 miles an hour and takes just 88 days to go completely around the Sun. Earth is speeding through space at 67,000 miles an hour and takes a little more than 365 days to circle the Sun. The farther out a planet is, the slower it moves and the longer it takes to go around the Sun. Pluto, once thought to be the 9th planet but now considered a dwarf planet, is moving at only about 10,000 miles an hour and takes about 248 years to complete its orbit. Each planet also rotates so that different sides face the Sun. It is the rotation of our planet every 24 hours that makes night and day. The Bible reminds us that when God made the earth and the heavens, He said, "Let the land produce living creatures." Genesis 1:24. The more we learn about the other planets in our solar system, the more we realize that only Earth could possibly provide a home for living things. What are the other inner planets like? The planets are often divided into 2 groups, the inner and outer planets. The inner planets are those closest to the Sun, and they are mostly solid rock. The inner planets are Mercury, Venus, Earth, and Mars. For many years, people have wondered what it is like on our neighboring planets. One astronomer 100 years ago thought he saw canals on Mars. Some people imagined there were whole civilizations of little green men on the other planets. Science fiction writers wrote imaginative tales of what life might be like on Mars and on Venus. But now the inner planets have been carefully studied by scientists. Space probes, pilotless spaceships filled with special instruments, have flown by each planet. Space probes have even landed on Mars and Venus. Today we finally know what it's like on the surface of each of these planets. Let's imagine that we're on an expedition to the inner planets. What would we find if our spaceship tried to land on each in turn? Landing on Mercury? Excitement grows as our ship approaches Mercury. Instruments on board tell our crew that Mercury is very heavy, perhaps heavier than we'd expect for its small size. Its average density is very similar to Earth's. Perhaps there are precious metals to mine there also. As we come closer, we examine the surface of the planet by telescope and find that Mercury looks very much like Earth's moon. There are flat plains and craters of all sizes. And look, there's the patch astronomers call weird terrain. Part of Mercury's surface has piles of giant jumbled up cliffs and shattered mountains. And on the other side of the planet is a great flat bowl, a huge crater that takes up 1/10 of the planet's surface. We realize that a giant rock from space must have struck Mercury, making a dent on one side, and so shocking the other side of the planet that its surface was literally cracked apart. Mercury is close to the Sun, and we've learned that it rotates very slowly. In fact, from sunrise to sunrise on Mercury is 176 Earth days. We'd better make one more check before we land. Mercury gets a lot of sunlight, and it looks hot. It might pay to make a temperature check. When we do, we discover that the average noon temperature on the sunny side of airless Mercury is hot enough to melt lead. We'd better not land on Mercury. If our spaceship didn't melt, it would quickly become so hot that we would literally be cooked inside it. and due to its slow rotation, the opposite shadow side of Mercury is extremely cold at -274 degrees Fahrenheit. Landing on Venus? We're hopeful as we approach Venus. That planet is about the size of Earth, and we can see that it's covered by clouds. What is under them? Since we can't tell through a telescope, we bounce radio and radar waves off the planet's surface. When we do, we're amazed at what we discover. Venus is rotating or spinning backward, but very slowly. Venus turns only once every 243 days. Underneath its cloud cover, the surface of the planet shows mountains and valleys. Many of the valleys are far deeper than Arizona's Grand Canyon. But can we land on that surface? Will we find a warm, green paradise under the clouds? The answer comes from space probes sent down through the clouds. The rocks on Venus glow dull red, and its clouds trap heat under them. Even though Venus is twice as far from the Sun as Mercury, Venus is hotter. The surface rocks on Venus are 870 degrees Fahrenheit. What's more, the air of Venus is very different from Earth's. Its atmosphere is deadly, made up almost entirely of carbon dioxide. And those clouds aren't water vapor like Earth's. They seem to be made up of droplets of sulfuric acid. What's more, the clouds are lit up from within by hundreds of bolts of lightning that flash every second. No living thing that we know could possibly survive on Venus. We turn away, realizing that we can never visit Venus, much less try to live on her. Venus, like Mercury, is a dead and hostile world. We land on Mars. Mars is only half of Earth's size, yet it has valleys and mountains larger than any on Earth. Mars has no water vapor, but as we approach the planet, we can see lines that look like dried up riverbeds. As we circle the planet, we realize there is no running water. Our tests explain why. First, Mars is cold. Its average temperature is 40 degrees below zero. What moisture there is on Mars is frozen. Second, the atmosphere around Mars is 100 times thinner than Earth's. In such thin air, any water on Mars would instantly boil away. Still, even though it's cold on Mars and the air is terribly thin, we can land there, and we do. One of the scientists who worked on the Viking probes, which landed on Mars, has described what we find. To get a feeling for what Mars is like, you might think of yourself being there on a camping trip, and your job is to try to make a fire and boil an egg. The first thing you discover is that there's no fuel on Mars. There's nothing on the surface of the planet that will burn, because there's only a tiny trace of oxygen in the Martian atmosphere. And finally, if you chipped some water off the polar cap, there is some water ice buried under dry ice, and put it in a little pan that was fueled by an electric heating device, you discover that the ice wouldn't melt into water. It would simply begin to disappear into gas, because water in liquid form can't exist on Mars. There isn't enough atmospheric pressure to allow it to remain a liquid. So that's Mars as we find it now, a dry, cold, desert-like planet with no possibility for life as we know it to exist there. Even though Mars is more like Earth than any other planet, we couldn't exist there. The outer planets. What if we turn away from the smaller planets that are closer to the Sun and try to explore the outer planets? What will we find there? Again, we know far more about these planets today because of space probes that have flown close to them, but nothing we find is encouraging. Jupiter, king of the planets. Jupiter has been called the king of the planets because it is the largest planet. It is so large that it could hold over 1,000 Earths inside it. But Jupiter is not a very solid planet. It is mostly made up of compressed gas, a slushy mix of ices and vapors. Most of Jupiter is made of hydrogen and helium, the two lightest gases. They are compressed by Jupiter's great size, even though its mass is about 300 times that of Earth. Jupiter is spinning rapidly once every 9 hours and 55 minutes. Its giant size and rapid spin set its atmosphere whirling violently in broad bands. Our ship could hardly pass through the greater than hurricane force winds, and even if it did, we'd find no solid place for our spaceship to land. But one fascinating thing has been discovered on our flight. Like Saturn, Jupiter too has rings, but its rings are made up of dark, dust-sized rock, unseen from Earth. Saturn, the ringed planet. Saturn is another giant planet, yet it is less dense than water, and its gravity is only a little greater than that of Earth. Like Jupiter, Saturn spins rapidly, once every 10 hours and 14 minutes, and it's cold, being over 8 million miles from the Sun. Again, we clearly can't land on Saturn, but as we fly by, we're fascinated by the bright rings that band the planet. The rings of Saturn contain thousands and thousands of icy fragments that reflect light. Why does Saturn have so many bright rings? Where did all their material come from? No one has a sure answer. Again, we clearly can't land on the soupy surface of this giant planet where winds rage at 1,000 miles per hour. We have to move on outward, farther away from the Sun. Uranus and Neptune. Uranus, just 4 times the size of Earth, is more dense than Saturn. This gas giant with a solid core rotates on its side, but backward like Venus. Due to this sideways rotation, Venus has winters that last 42 Earth years. Since Uranus's average temperature is 350 degrees below zero, we decide not to try to land there. Neptune is almost a twin of Uranus. At its closest point, Neptune is over 2.6 billion miles away from Earth. So not very much is known about it except that it's too cold for us. Not ready to give up, we travel on to Pluto, once classified as a planet, but now considered a dwarf planet. It is not only smaller than Earth, it is probably smaller than our moon. Pluto appears only as a faint dot of light even to Earth's largest telescopes. It was not even discovered until 1930. A study of its surface suggests that Pluto is probably composed of frozen methane gas and weighs only 1/5 as much as our moon. Since Pluto is gripped in unbelievable cold, we decide there is no use in approaching it, and we turn our spaceship back toward home. Dead planets. On the way back to Earth, we consider what we've seen. Life exists in our solar system, but only on one planet. Each of the other planets is not only dead, but sooner or later would destroy any living thing that visited it. Actually, our voyage to the planets was unnecessary. We could tell from Earth that they are dead worlds. The law of entropy, also called the second law of thermodynamics, tells us that they must be dead worlds. On a dead world, chemical reactions have run down. Such worlds are in equilibrium. No fresh chemical activity takes place. The baked surface of Mercury is powdery and dry, its elements condemned to disorder. Neither Venus nor Mars could support life, for their atmospheres are well known to be in dull chemical equilibrium. These can only be dead worlds where atmospheres are almost entirely without oxygen. The outer planets offer no hope for life. They are cold, composed of light, liquefied gases. We would be crushed by their deadly and ferocious atmospheres. No, these are truly dead and deadly worlds. The odd planet. Even from space, Earth looks different from the other planets. It hangs there bright and blue, its skies dotted with floating white clouds. It hangs on the emptiness circled by the moon, looking warm and friendly. Astronomers have rightly called Earth the odd planet. In so many ways, it is different from all the others. The other inner planets are pitted by craters caused by the rocks that hurtle through space. The surface of Earth shows fewer signs of craters. Moons of other planets are not nearly so close to their planet sizes. Our moon is 1/4 the size of Earth itself. Earth's atmosphere is made primarily of nitrogen and oxygen gas, with water vapor. The other planets appear pale yellow or orange or pink or red. Not one has the free oxygen that is essential for life. What's more, only on Earth does water exist as liquid on the surface. It is water covering 2/3 of our planet with its vapor suspended in the air that makes life possible here and gives our world its beautiful blue hue. In each of these ways, and in many others, Earth is unique in the solar system. It is as if Earth were purposely hung in space at just the right distance from the Sun and provided with just the right amount of every element needed for life to exist. It is no wonder that astronomers, who have compared what we have on Earth to everything they have found in the solar system, have called Earth the Mystery Planet. They realize that Earth is different, but they have no real explanation why, except to suggest that every condition needed for life to exist on Earth has just happened. Why is the Sun so important? Nearly all the energy used by living things on Earth comes from our Sun, which is at the center of the solar system. So for us, it is by far the most important object in the sky. Yet our Sun is just one of 100 billion stars in just one of the universe's 100 billion galaxies. Most of the stars in our galaxy are either red stars, whose surface temperature ranges from about 4,000 to 6,000 degrees Fahrenheit, or are blue-white stars, whose temperature is 10 times hotter. Our Sun falls in between this range and has a surface temperature of over 10,000 degrees Fahrenheit. Our own star is one of the smaller and more unusual, a yellow dwarf. It is an unusually mild star, yet we can hardly imagine the awesome power it produces. At the Sun's core is a nuclear furnace, whose heat is at least 15 million degrees Celsius. Tiny particles of light called photons, which carry the light and heat energy our Earth needs, are produced in the Sun's core. Around the core is a wide band of slightly cooler, but still compressed and blazing hot gas. To picture what happens, imagine a photon rushing away from the core. On its journey, it runs into atoms of gas. It bounces off and within a fraction of an inch runs into more atoms. Back and forth the photon bounces, moving up and down. Each time it hits and bounces, the photon loses some of its energy. Finally, the photon reaches a place where great bubbles of boiling gas form and hurl up towards the Sun's surface. Carried upward, the photons are finally flung out into space. How long does it take a photon to get from the core to the boiling surface of the Sun? The present estimate is that a photon must travel for 10 million years, but that long journey is extremely important to us. If the photon had not lost untold energy in its struggle to the surface, it would be a powerful ray that would destroy living things on Earth. Even the structure of the Sun seems to be designed to bring us safe energy, warming and supporting life on Earth rather than destroying it. Even though photons have lost much of their energy in the journey up from the center of the Sun, no life could exist on Earth if we were not also protected by an envelope of air and a magnetic field. That magnetic field repels most particles that stream toward us from outer space. As we'll see in another chapter, our atmosphere, which stretches up 18,000 miles from sea level, further protects us from the Sun's rays. How important is it for our Earth to receive just the right amount of energy from the Sun? Even a tiny change would transform our planet. Just 1% less energy and Earth would soon be covered with ice. Just 1% more and Earth would soon be unbearably hot. Yet the energy Earth receives is just right and has remained just right through all human history. A zone of life. Earth alone in all the solar system contains a zone of life. Only here can water remain liquid and oxygen abounds in free active form. While all this may seem odd to people who do not believe in God, nothing about the earth seems odd to the Christians. The Bible tells us that the earth is the Lord's and everything in it, the world and all who live in it. for he founded it upon the seas and established it upon the waters. Psalm 24, verse 1-2. Another praise psalm in the Bible also focuses on water, one of those things which makes earth so odd. As you read the psalm, think about the specialness of our earth, and think about the special concern God shows for living things. He set the earth on its foundations. It can never be moved. You covered it with the deep as with a garment. The waters stood above the mountains. But at your rebuke the waters fled. At the sound of your thunder they took to flight. They flowed over the mountains. They went down into the valleys, to the place you assigned for them. You set a boundary they cannot cross. Never again will they cover the earth. He makes springs pour water into the ravines. It flows between the mountains. They give water to all the beasts of the field. The wild donkeys quench their thirst. The birds of the air nest by the waters. They sing among the branches. He waters the mountains from his upper chambers. The earth is satisfied by the fruit of his work. He makes grass grow for the cattle and plants for man to cultivate, bringing forth food from the earth, wine that gladdens the heart of man, oil to make his face shine, and bread that sustains his heart. Psalm 104, verse 5-15. Yes, the earth does belong to God. This planet is odd because God has shaped it as a home for you and me and for all living creatures. How important then we must be to the Lord.